So in the last tutorial, we covered scraping static web pages using Arvist, but this time we're going to talk about scraping pages that use JavaScript. So I'm going to use this web page right now, which shows the prices for an Amazon service for people who want to purchase more space on the cloud to host their websites. So if you scroll down, you'll see that there's a bunch of tables here and that they're interactive, so you can pick these different regions and the table inputs change. So if I try to read the HTML and extract the text using the HTML text function, you'll see that it won't work. So it says here, sorry, pricing information requires JavaScript. And when you go on here too and use the selector gadget, you'll get this CSS selector right here. So in order to get around this, we're going to use a program called PhantomJS, and you can install it using the link that I posted on the web page. But basically what you have to do is save the extension in your working directory. So my working directory right now is set to be the desktop, and you should always keep in mind what your working directory is, especially for this tutorial. It's going to become really important later. So we can just take a look at PhantomJS, and basically it's a program that's run on the console. So right here, this is where, this is the pathway to PhantomJS right now. So you can see users, Apple, desktop, PhantomJS. This is where it is, and this is my desktop. So the lines within this highlighted section, basically what it does is take the URL and create a JS file from that, and then it writes it using the JS Phantom program to create an HTML file from that JS file. And then we read in that HTML file as if we were reading a regular site off the internet. And then you should be familiar with these lines of code right here, which is just extracting the nodes, except this time we're using an Xpath Selector, and I'll talk about those later. And I'll show you this other function here called HTML table, because last time we used HTML text. So first I have this object here called URL, which is the URL, and then this object here, connection, which is the name that I want to call my JS file. So now I have my object URL and this object called connection. So what the write lines function does is it takes lines from the web page given by the URL, which we specified right in here in the function, and writes it to a file that we've called AmazonPricing.js. So here, this argument con equals connection, which we've specified to equal this file. And so when we run this, you'll notice that in the working directory, you now have a file called AmazonPricing.js. Don't worry about the lines of code inside the sprintf function. Basically what this is doing is this is writing this JavaScript in here into the PhantomJS program to create this. And then what you want to do next is you have to specify the OS command for the system function. And so I've broken it up into the separate step here where I've created an object called system input and specified it to equal the pathway to my PhantomJS program. So if I open PhantomJS, you'll see that the pathway to it is users, Apple, desktop, and PhantomJS, which I showed earlier. And what you want to do is this line right here says we want to write Amazon Pricing.js to this new file that I'm going to create called Amazon Pricing HTML. And this is going to create the HTML file from the JS file that you're going to read. And so now when I use the system function on system input, I have this HTML page now called Amazon Pricing. And then we can do what we did at the other tutorial where I read in the IMDb page and use the read HTML function. And so you should be familiar with this section right here. The difference is we're going to use an Xpath selector. So I put a link to a cheat sheet for Xpath and CSS selectors here. But the general idea with Xpath selectors is you use these, use 2 backslashes and the name of the element that you want to select. So here we have 2 backslashes and a table because we want to access the tables in the web page. And you can select different like elements by having a number. So here I'm saying I want to specify the 4th table. And then I'm using a new function called HTML table. And if you read the page above, you should know what it does. It basically creates a table instead of just extracting the text. So when I run this, I'll now have an object called table. And you'll see here that I've collected the information from the 4th table into the form of a table. But if you notice on the website, the table I've created looks different from the one on the site. And that's because the formatting of this table is a little strange. So we have this heading right here for these rows, and it doesn't have the same number of rows and columns that are filled out. And so we get the formatting to be incorrect when we use the HTML table function. So instead, what I'm going to do is I'm just going to do HTML text. And this line right here, the TD, specifies that I want to collect it by columns rather than rows. If I wanted rows, I'd use TR. So you can check out the cheat sheet here to learn more about Xpath selectors. And so instead of selecting the 4th table, I'm selecting all the tables. So if I run this, you'll now see that I have all the tables as a vector. In this case, where the formatting of the table is not clear or conventional, where you can use the HTML table function, I would suggest turning it into a vector and then formatting it yourself. So if you notice, there are multiple sets of tables on this page, and they all have different dimensions. So if we look here. So what I've done in the code here is I've broken up this vector into different sections that specify the different types of tables. So you should be familiar with the code here. I'm basically just subsetting vectors and turning them into a matrix. So if I run this code right here, which formats it, you'll see that I have 3 matrices now. I've got table 1, table 2, and table 3, and I'm going to write these as CSV files. And so now you'll see that we have CSV files of the tables that we extracted off this website. So if you look on the same R file that I posted, you'll scroll down and you'll see that I've created a function called Scrape.js, which basically performs the same functions as what we did above. So if you look at the input to the function, it's the name of the URL, the name that you want to call the JS file, the default is scrape, and then you want to put in the path to PhantomJS. So it's on my desktop, so right here, this is the default for the function is set as my path to the JS Phantom extension. And then here is the node that you want to call it. So this could be an Xpath selector or a CSS selector. So the default is a table. The code in the middle right here does the exact same thing. If you'll notice, it's set as HTML_text. You can change that to a table if you want, but I find that the HTML text to be the most flexible, and it allows you to format the table the way you'd like. So the thing I want to emphasize is that the function right now, using the default node and HTML_text, it will return the tables that you extract as a vector. So at the bottom, there's another example where you can scrape this website here showing batting stats for the Red Sox this year. This is kind of a terrible example because you don't need to use JS Phantom, but nonetheless, it's a good example for scraping tables. And the code right here just does the same thing as above and formats the vector into some nice tables. There's also another example here where you can scrape global elections